Hello, we are KLNA Structural Engineers and Builders, and we're here to talk about the U.S. Olympic and Paralympic Museum that's in Colorado Springs. But first, I'd like to make some introductions. There's three of us from the team here. I'm Greg Kingsley, the President and CEO of KLNA.
And I'm Jeff Myers, the Engineer of Record and Project Manager for the museum.
Hello, my name is Michael Olson. I'm with our steel detailing group here at KLNA, and I was the project manager for this project.
We were really lucky to work on this really extraordinary building, and preparing for this interview really put me in the mind of wondering what is it that really makes a great building. And of course, it always starts with a visionary owner with a clear purpose and a visionary architect, as we had in Diller, Scofidio, and Renfro, and Anderson Mason Dale here in Denver. And I'll never forget Liz Diller's first sketch for this building, which is really just like a few lines in a scribble, but it clearly indicated this sort of leaping athlete with very touching the ground, leaping towards the mountains. And that kind of set in place this notion of a metaphor of athleticism and movement and dynamics throughout the project. And, you know, the notion of making a building look like it's leaping off the ground became a thing that we embraced throughout the project, together with a lot of other sports metaphors. Another being that Olympians work sometimes in individual events and sometimes they work in team events. And this was, beyond a shadow of a doubt, a team event with everybody from the owner to the architect and us, sub-consultants, subcontractors and contractors, you know, throughout the system. There was just a ton of communication and collaboration throughout the process. Another metaphor for me is that Olympians and Paralympians all face obstacles, and some of them seemingly insurmountable obstacles, as we did in this process. But the athletes solve those by a ton of practice and visualization and seeing their way through, maybe even before they get out onto the sports field. And that's the way we did it too. So what kind of obstacles did we see? Well, you know, maybe the first would be just the notion of making a building look like it's lifting off the ground. And the second, how do you put a framework behind this doubly twisting skin that surrounds the building? And, you know, lastly, the challenge of making that building in that shape a constructible building, one that could be easily erected and smoothly. At KLNA, we faced that last challenge through what we call the integrated mindset. The idea of, you know, stated simply, really setting engineers and steel detailers next to one another to solve the problems of design and the problems of construction simultaneously. And Jeff and Michael are going to tell you some of the stories about that through the process. Jeff?
Yeah, thanks, Greg. The structural steel was really the only material discussed for the museum superstructure. Steel's ability to be cut and re-welded and assembled back into highly custom shapes and assemblies for this project was really the key for achieving the architectural intent and the iconic nature of this building. When KLNA joined the team, there was a structural concept of a long span truss system that was set just to the inside of the exterior skin. Through early meetings with the contractor team of GE Johnson and other steel subtrades, constructability became a major concern with that structural diagram, and KLNA was challenged to find another diagram that worked more for the benefit of constructability for our teams in the field. Where we finally landed was a slightly more traditional system utilizing posts and beams. Posts and beams, however, needed to accommodate the overhanging nature of the skin system of the building, as well as being responsive to 18 floor levels in the superstructure of this three-story building. To achieve this, the columns needed to lean out, and beams are cantilevering, and cantilevers upon cantilevers, that it all reaches out to support the skin system. While this leaning and cantilevered structural diagram solved many of the constructability challenges, the system created more engineering challenges for us. The main challenge was the gravity system of a reaching and leaning structure induced non-transitory loads into the lateral system. While most buildings' lateral systems only support wind and seismic loads, this museum's lateral system is under constant stress due to the everyday gravity loads of the building. In order to achieve this unique load path, along with the constraints of the skin and floor elevations, our integrated engineering and detailing team worked side by side to solve load path and coordination hurdles. Hey, Michael, can you speak to an example or two of this?
Yeah, thanks, Jeff. One with the skin system in particular, one challenge that came across was due to economic and constructability constraints. There was a fairly major redesign of the support system that went behind the skin once we were already a good chunk of the way through the detailing. So to solve this problem, since KLNA was the engineer and the detailer, we literally, myself and Nick Trombetta, the design engineer, pulled up 2 chairs next to each other in front of one computer screen and pulled up the steel detailing model. And it was mostly a geometry problem. So we took that model and we went around the building and solved all the nuances to the geometry to make it fit within the skin system on this complex project. So once we solved the geometry problems, Nick took it back and did the analysis, made sure the connections all met loads and all that. And it was a non-traditional way of approaching the problem, but due to schedule constraints, we didn't have time to do the traditional, analysis, then structural details before it got to the detailer. We kind of flipped that on its head and solved it a different way. And also speaking to the skin system, it was so custom that each of those scales behind you, Greg, there were thousands of them and no 2 were the same. They were all custom and they had such a tight tolerance for installation that on the steel side, we knew that we had to meet that same level of tolerance for the steel structure that got put behind it. So there was a fairly intense model coordination effort with the skin system supplier, and with our steel detailing model, there was lots of model exchanges. And then that fed down to our awesome fabrication and erection partners. Drake Williams Steel did a great job with the fabrication and building it to those tight tolerances, and then putting it up in the field. LPR Construction, they knew they had to put it in place exactly right. And once it was in place, we did a 3D laser scan of the project, brought that back into our virtual built models, and we could see that the steel was in place within 1/4 to 3/8 of an inch or less. For this building that has no square corners and hardly any vertical columns, that was an amazing feat to get the steel in the air with such precision, allowing this cool, unique skin system to be put on. So it definitely took a team effort to get this steel structure in the air.
Did we have, Jeff, like 6 RFIs on the project? Or
6 RFIs for the structural steel. Yep.
It's impressive. I just want to say in closing, it's clearly an extraordinary building and it involved an extraordinary effort for sure, but we'd like to think that the integrated processes that we used and the way the engineers and detailers work together should make any project work better. So we would like to think we set an example for all steel structures, just in terms of collaboration, coordination, and integration of those processes. Thank you very much for giving us the opportunity to talk about our project. Thank you.